Assalamu alaikum. This is the code explanation video. So instead of showing the code from Might, I am showing it from an HTML file. Actually, in the HTML file, I can zoom in and out, so it will be easier to see. So at the very beginning, we are doing some necessary tasks like moving the stack pointer to 70. Otherwise, it collide with register bank 1 to avoid the conflict with register bank 1. Then we have moved our PSW to 0. Select register bank 0. Then we are doing some necessary things that makes our life easier. Otherwise we have to every time call pin 1.0 1.1. We have to remember this one, so while coding we can use this fan, rs, enable, awr. This fan is connected to motor pin in 1. Okay, see, here it is connected to motor pin in 1. So using this pin, actually what we did, using this pin we are sending our in 1 pin, we are sending our pulses to control the motor speed. Okay, if you can remember from the previous videos. So this is the task of the fan. Then rs, enable, these are for lcd, to run our lcd. Actually lcd has two modes, command mode and another is display mode. So to send a command, actually maybe rs we have to set 1 or 0, I couldn't remember actually, and for another one we have to set rs equals to then 1 and or 0. If 1 for command then 0 for display, or if 0 for command then 1 for display, like this. So these are for rs, and also enable pin, and this awr pin is for lcd write pin. If you can see, WR pin of LCD 1 point, sorry, ADC, not LCD, ADC. WR not pin of 1 point here connected to pin 1.3. This is the same pin here. Okay, so this is called AWR. Then some LED pin and buzzer pin. Okay, so LED pin are actually, these are the LED pin. Okay, uh, for low speed we are showing one LED, for medium speed we are showing two LEDs will be blinking, and for high speed we are showing three LEDs will be blinking. So in this way we have connected, and another pin we have connected to buzzer. So I we have declared all of this here. Okay, now at the very beginning we need to clear these pins. Okay, we know that when we start our code, initially what happens, all the pins are set. Okay, initially all the pins are set by default. So we need to clear this pin. Otherwise what will happen, if we don't do these things, our fan will be running from the beginning. Okay, if we don't do this, and for LEDs, these LEDs will be turned on automatically at the beginning, if we don't do this. Okay, then buzzer is active low. We have made this active low using this not get, and in hardware it is already active low. Okay, active low buzzers, we have to give low pulse to turn it on and high pulse to turn it off. So to turn it off we have actually set bit buzzer. Okay, like this. Then some codes for LCD installation, you already know that from the class of LCD, that we have to do these things to actually start our LCD. For example, 38H, 2 lines, 5 into 7, then 0EH for display on, then 01H clear the display, and 06H to move the cursor from left to right. Okay, then at the very beginning we have moved our cursor to first line, position 1. Okay, then shown our first message. If we see from here, sorry, we start this again. Okay, so we started this. Uh, this is the first message. Okay, this is the first message. We have shown this one. Then move to second line. Okay, we have moved to second line and showed the second message, right? Showed the second message. Then we have cleared our LCD. Okay, we have cleared our LCD. Then move dptr to message 3 and showed our third message. Okay, so let's see what is our third message. This is our third message. So after calling third message, we have called a function called temperature in. Okay, so let's see what this thing do. Okay, so we will move to temperature in. So this is the temperature in. See, if I now write start this one without giving an input from the keyboard, I cannot move to next messages, okay, or next line. I have to must give an input from the keyboard. So it also does the same thing. Okay, when I call temp in, it is asking an input from the keyboard. Okay, this one calls a function that asks from keyboard, and after when I give my first input, for example this one. Okay, so this one is when this one goes to actually this one does not show here automatically. We have to perform something. Okay, so after pressing 1, after pressing, when I press the first one, what it do, it moves it to R0. Okay, then moves it to R0. Okay, and shows it using the LCD, shows it using the LCD. Then it calls again another keyboard function. Okay, so here you can see that it is asking input from me. Okay, so if I give my second input, now it is moved to next, but internally it has from some functions. Okay, what it do, it perform these lines. Okay, so what is the purpose of this line? Okay, so I have given input 1 4, I have given input 1 4, but to compare this value, I need some I need it in decimal format, right? So I have given this 1, then given this 4. So but I need to convert this 1 4 to a number 14, otherwise I cannot compare this one. So in this part it is doing these things. Okay, to convert this one, I actually what I did, I moved R0 to A, then multiplied it 10, then add R1. Okay, so if I actually show it from here, at first what I did, I multiplied 1 with 10, then what it becomes, it becomes 10, then added this 4 with it. Okay, 4, then 14, this is the number. So now we'll save this one in a register. Okay, we'll save this one in a register. So if I show it here, we are actually saving it at first at the accumulator. Then when I call the return, uh, if I move it at the beginning, so you can see third message. So to save it, we are not using the register bank 0, we are will be using the register bank 1. Okay, I have moved the register bank to 1, then saved the first this was our minimum temperature, right, the first one. So I have saved in R2. Okay, then after saving it, I have actually cleared the register bank. Then short delay is called, then we moved to our message, we move to the next line. Here you can see we have moved to the next line, then showed this message median temperature, and again this is asking another uh, input from the keyboard. Okay, why? Because we have again called what, this one L call temp in, so it will again uh, ask another input. So let's give another input. So I have given input 25. So automatically what it will do, this our code. Now convert this 25. Actually, at first I have given 2, so it will multiply it with 10 and make it 20. Then I have given 5, it will just add it and make it 25. Now I will save this one. Okay, so where first message was saved in register bank 1 R2, next one is saved in see register bank again I am making it register bank 1 and saved in R3, right? So in this way, now again we'll clear the LCD. So first one was a minimum temperature, next one is our median temperature. Now in this way we'll again get the maximum temperature and at last get the critical temperature. Okay, so right, maximum temperature, let's say this is 35. Okay, and in the same way critical temperature, let's give it see if I don't give any input, it will just hold this in this line for infinity. Okay, so I have to give input, some input. Okay, so 50, right? So up to that part I think this will be clear. Up to this all of these are just we are getting the input. Okay, uh, up to this part we are actually getting inputs. Okay, so see the temperature first temperature is minimum temperature is saved in this R2. Then actually we didn't use R0 and R1 because they can be also used for indirect addressing, so we didn't use that one. We started from R2. Save the minimum temperature in R2, then next temperature in R3, then the next temperature media maximum temperature. So here is the mistake, this will be store maximum. Okay, store maximum, store minimum in R1, then medium, then maximum. Okay, this will be maximum. Then actually we have saved the critical temperature also, so here is a mistake. Now after all of this we have cleared the LCD and called another message. Okay, so what is this message? This is this temperature, this message. Okay, so this message we don't need to clear this one. Okay, we'll just actually this message will be part of our simulation for the next whole time. Okay, this temperature one, so we have called this one message 7. If I go at the bottom, see message 7 temperature. Okay, and kept at the very beginning this was blank, and after some time it will be updated. So let's see how it will be updated. Okay, so now at the beginning again these LEDs are cleared. Okay, to avoid any mistake. So in the next part we'll see some LEDs will be turned on, so where this loop will be running like continuously. So at the very beginning we are clearing these LEDs and also setting the buzzer. Okay, turning off the buzzer, this are we are doing this in every loop. Okay, so at the very beginning I have set the position to 8C. Why 8C? If you see this is T, this is for temperature 80, then 81, 82, 83, 84, 85, 86, 7, 8, 9, A, then B, and this 20 is at 8C. Okay, 8C. So I have set the position, moved the LCD cursor position to 8C. Okay, then what I did, I asked the ADC to convert my value that it will be getting from the temperature sensor. So it is getting a value from temperature sensor, then this value is going to this ADC and it is internally converted, then it is moved using this pins, it is moved to the microcontroller. Okay, so if you see here set bit ADC, then clear, actually we have to give a low to high pulse. Okay, so this low to high pulse is given here, sorry, high to low pulse, high to low pulse we have to give here. So every time it is doing these things. or low to high pulse, maybe low to high pulse. Yes, actually, in every line this part is making clear. So at the beginning, to high, we are giving high to low pulse, we are making it high, then again this clear is for the actually next conversion. Okay, this clear is for next conversion. So every time we make it high, automatically the conversion starts. Okay, so in the hardware we don't need this part. Actually, in hardware there is an internal pulse for WR, it is automatic, so we don't need to give this pulse. So see, the value we got from port 0, the value we got from port 0, this is going to the our accumulator. Okay, going to our accumulator. Now we need to compare this one, right? We need to compare this value. So what we did for conversion, actually we need to this value, this is coming as, what should I say, uh, direct value. So we need to convert to show this one. We can actually compare this one, but to show it to LCD, for example, uh, now the temperature we are getting is 20. Now the temperature we are getting is 20. So if we just move this to LCD, it will not show. Okay, we have to show digit by digit. Okay, we have to first get this digit, then this digit, we have to show it one by one. So how to do it? Actually we will divide it by 10. So let's say it is not 20, it is 25. Okay, for okay, let's say it is 25. So if it is 25, it is divided by 10 to 20. Sorry, then 5 is our remainder and 2 is our content. So we'll first show this digit, then this digit. Okay, so actually we are converting this decimal to ASCII. Okay, binary to ASCII or decimal to ASCII. See, at first we are dividing it by 10, then storing the tens digit first, then the units digit. So we'll at first showing the tens digit. Okay, see, showing the tens digit first, then showing the one unit digits. So actually we need to actually convert this one to ASCII also. So to do this we are adding 30. See, this 30 is for converting it to ASCII. Okay, now we have shown this part, then we are moving to it, moving our message to C0. Okay, C0 position. This is for this thing, minimum to medium. For this one we are moving it to C0. To to get this message, actually we need to compare, right? To see where is our temperature now, we need to compare this one. Okay, so already our temperatures, the input temperatures are saved in some register, right? Input temperatures are saved in some registers. Which registers? So at register bank 1 we already saved this one, register bank 1. At R2 position we have saved the minimum temperature, then R3 position we have saved the medium temperature, R4 maximum, and R5 critical temperature. These are from register bank 1. Okay, so we'll now compare the input temperature with this one. See, our input temperature is saved in R2, right? Which R2? This is not this R2. This R2 are different. Okay, this R2 and that R2 are different. The input temperature, the temperature from ADC. Okay, this is also saved in R2, but R2 of register bank 0, right? Register bank 0, and this R2 is register bank 1. So we have to be careful here. every time we for comparison we'll be actually setting our value register bank to 1 and then again clearing it. So let's see the code. Okay, so again we already saved our R2 for comparison. We have stored this one R2 for comparison purpose, so we'll again get this one from R2 to accumulator. Now we'll compare our accumulator to our values. Okay, so at first see, I have made set bit to PSW to 3. Okay, cleared the carry. So now the now the what should I say, the comparison starts. So this R2, now what I did, I moved this R2 is already we have moved to register bank 1, so this R2 holds our minimum temperature, right? So we moved the minimum temperature to B and now compare this one. Okay, see, compared this A have the temperature from ADC and B have see, B have temperature from register bank 1, the minimum temperature. So we are comparing our temperature from ADC to with our temperature from T minimum. Okay, so if this is not equal, then we have to check whether it is greater or less, right? So if this is jump carry, right? So jump carry means ki A is less than B. Okay, jump carry when there will be carry. If A is less than B, then there will be carry. So if A is less than B, what is the condition there? It means our input temperature is now is less than T min, so we have to make our motor stop, right? So see, if jump carry, we have moved to less than R2, and less than R2 means temperature is less than minimum. Okay, right? uh, so here there should be a T. Okay, there should be a T. If I open the might, let's change those. One thing was minimum temperature in register bank R2, then medium temperature in R3. Okay, one mistake was minimum temperature, then get medium temperature, maximum temperature. Here it will be max, right? It will be max. So then here we'll be given a T minimum jump. Okay, so where here will be if T is less than T minimum, we'll move to less than R2. Okay, so what happens in less than R2? Let's see. Okay, in less than R2, we are clearing our fan, turn it off. Actually, in less than R2, our when the temperature is less than T minimum, then our motor will not run. Okay, so we have cleared our fan to stop it and call the delay, short delay. Okay, then after doing this, actually what we did at the beginning, see, before checking, we are actually making the set bit PSW, so we have to actually clear this one, right? So less than R2, we are clearing this PSW, then showing this message. This message holds this message, right? uh, T is less than T minimum. T is less than T minimum. If I, so which message? This message. Okay, T is less than minimum, this message will be shown here. Then uh, move to finish C, and finish C, we are again starting from the beginning, right? We're starting from the beginning. So let's move the next comma, next comparison. Okay, so if this if this is not less than R2 is not less than R3, then it will check this one. Okay, this one, actually this one. If we don't find any carry, it will move to the next one. Okay, so for compare now, what we'll do, we'll compare with R we'll compare now with team medium. Okay, at first we have compared, see here, at first we have compared with team minimum, then we are comparing team medium. Okay, see, first compare R2, this R2 holds T minimum, then R3 holds T medium. I have written it here. See, R2 holds T minimum, R3 T medium. Okay, so temperature, minimum temperature. So now we are comparing minimum temperature. So if it is less than minimum temperature, what it actually means, if now if it is less than medium temperature, it means it is more than minimum temperature, less than medium temperature. Okay, this line means, this line, if we pass this line, it means it is more than more than T minimum. And if we found a carry here, it means it is more than T minimum and less than T medium. So we'll now move to between R2 R3 this function. Okay, so here we are actually giving a low temperature, low fan speed. So how we are doing it, so in this part one LED will be on. See, we are turning on one LED. Okay, and then clearing the fan, clearing the fan, see, we are giving more delays to the lower part and less delay to the high part. Okay, so motor will be running at a low speed. Then we are clearing the PSW, moving the message, next message. What will be the next message? Then the next message will be like this one. See, this one. Okay, this message will be moved, we'll be showing this message, then we'll again start from the very beginning of the loop. Okay, then we'll then compare with which one. See, now we are getting the next temperature. R4 holds which one? R4 holds, R4 holds maximum temperature. Now we are comparing maximum temperature. So if it more than medium temperature, then we are comparing it maximum. So if it pass this line, if there is no carry, what it means, it is more than the medium temperature. Medium temperature. So we'll now compare this one with the maximum temperature. So if it is, if A is less than the maximum temperature, then this line will be true. We will move to between R3 and R4. See, in R3 and R4, between R3 and R4, this one, we are now turning on two LEDs. Okay, so we are clearing the fan. Now compared to this one, we are giving less delay here. See, in clear fan less delay, and in set bit one delay. You can ask me a question, actually, why we are giving only one delay here. Okay, so if I tell you, this line is this line then move to jump message, then goes to finish C and start from the beginning. So here many lines. Okay, so L call delay is, it may seem that it is very small. Okay, but it is actually much bigger. Okay, and here we have kept both of this same one times to actually make our output a bit good. Okay, so we have just tweaked it manually, but we are making the lower part. Okay, actually if I draw here, previously, let's say previously clear was this part. Now we have decreased this one. Okay, we have decreased this one, so most of the times our motor will be on now. So speed increased, right? uh, so see, from this part to this part, speed increased, right? So now we'll again compare the next one. If it is more the maximum temperature, more than maximum temperature and less than the critical temperature, right? R5 contains the critical temperature. Okay, R5 contains the critical temperature, R2, R3, R4, R5. So if it is less than critical temperature and more than the maximum temperature, we'll move to another part. Okay, this one between R4 and R5. See, R4 is our uh, maximum temperature and R5 is our critical temperature. So in this part we are turning on 3 LEDs. Now see, in this part our fan will be running at our full speed. So we have only set bit. We have no clear function. Okay, no clear function. We have only set bit. Then clear in the PSW, showing the message, and then again start from the beginning. And the last part, when our if it is greater than actually what it happens between R4 and R5. Okay, now if this actually bypass this line, then what it means, it our T is greater more than 3 critical. So in this part we have to make our fan off. Okay, when T becomes more than 3 critical, we have to make our fan off. Then we have to turn on the buzzer. Okay, to stop the buzzer we have made it uh, uh, set bit to run the buzzer. Will make it clear. Then we are making the PSW clear, showing the message and starting from the beginning. Short jump finish is starting from the beginning. So up to this part is clear. Okay, now there are some subroutines. These subroutines for our command of LCD, this one for display of LCD, this one for message part. Okay, and this temp pin I have already shown. This one it calls the keyboard 2 times. Okay, for first one for the actually lower digit of higher digit of our temperature, then the lower digit, in this way. And these are our delays. We have actually create two delays, one short delay, another one long delay. Why long delay? One medium delay also. I actually forgot which delays in this part actually. If you can remember, one delay was specified from the uh, book that we have to maintain this delay. So this delay is this part. Okay, we have to keep this one like this. So I have decreased the LCD delay to show the message a bit fast. Okay, and another delay, these delays are a bit longer. Okay, then another delay was between the message, between the commands, we have called another delay. So we have used three types of delay. Okay, one delay is bigger than the another. Okay, so this one, maybe this one was the short delay, then a bit long delay, and this one a medium delay. Okay, so we can actually change this one. And this part is for the code or keyboard. Okay, so this part is a bit different from the code of our book, right? So here is a problem. The problem is uh, these portions are uh, these portions KEs are for our rows, and K1 KB, these are for columns. Okay, so these are mistakenly written, and these parts are a bit similar from like our book. But in the book, if I show the book, so this is the code of the book. Okay, we are moving port 1 to 0, and where the port 1 is connected, port 1, this is the port 1 rows. Okay, we are making the rows 0. But see, we have used different ports here, but in our circuit we are using the same port for rows and columns. So now what we have to do, we have to do bitwise operation, right? We can't make the whole port 0. Whole port we cannot make this 0. We have to make this port first 0, clear these ports. Okay, so sorry, we have to make this set bit, right? If I show the code of the book, we have moved at port 2 we are moving ff, and port 1 we are moving 0. So which one is port 2? Port 2 is column, so in column we have to move ff. Okay, so if I show the code, see, 4 pins are set and another 4 pins are cleared. Which pins are cleared? See, these pins are cleared actually. These pins are cleared. Like the book, these pins are cleared, but in the book we what we could do, I can actually make the whole port. Now we, as we are using the same port for port 2, like we have mixed these rows and columns, we have to do bitwise operation. Nothing much change here. We are doing bitwise operation. All the uh, change are in bitwise operation. See, uh, when instead of moving this one, instead of let's say move port 1 1 1 1 1 0, we actually we need the last 4 digit, right? 1110. So we'll be doing this thing. See, uh, we are doing the same thing, but bitwise operation. Okay, so there is some mistake. We have cleared ke4, but according to book we should cleared ke1 first. Okay, so when I use this code, there was showing some error, like when I pressed 1 it was showing 3. Sorry, when I pressed 1 it was showing minus. When I pressed 4 it was showing like this one. So what I did to just match this one, I have changed the keyboard lookup table. Okay, so this lookup table is for our hardware. Okay, this lookup table for our hardware, and for to match with the like board, and in the software you will see a different lookup table. Okay, software lookup table is different. If I open the software one, see, this one is a bit different. Okay, so actually I made some mistake in the rows and columns to identify the pins. So this mistake was actually corrected by just changing the lookup table, nothing else. When I pressed 9 it was showing, for example, when I pressed 4 it was showing 9, so I have moved 9 here. Okay, in this way I changed this one. Okay, uh, so this is the code of the keyboard. Okay, and at last these are the messages and keyboard lookup table. So the code is a bit long, but this LCD code, I have the LCD code and keyboard code I have not shown in details. These are just like our book. Only change in keyboard is that we are using bitwise operation. So instead of moving all the 8 bits, we are using 4 bits at a time. See, 4 bits at a time. Okay, like in this way. So that's all. Thank you.